morning, everyone. We are the group consisting of Bie, Flores, Llaban, Candontol, and Mariano. Today, we are going to be presenting our project for our basic calculus class, which is all about creating an image for our institution, CGHC. Presenting its core values, let's go! Our logo was inspired by the core values of Chinese General Hospital colleges: the brain, which represents civic-mindedness, the key, which represents knowledge that will be attained to reach success, and the book, that represents the value of the institution as a key player in nation building. Then, the Philippine flag and Chinese flag as a depiction of solidarity of Filipino-Chinese community. Also, the alibata or baybayin can be read as Buhay Bayan, since CGHC trains its students to value every person and to be an individual that is willing to be used by its own country. Then the Chinese characters can be read as Chinese General Hospital Colleges, which is the name or title of the institution. Lastly, the whole logo portrays the assimilation to the Filipino way of life. I will now explain my part in the project by showing you how I made the light bulb, outline, shading, and the details of our logo. I first started by making the sign functions first, because I thought it would be the foundation for the shape of the light bulb. Right after doing the sine waves, I proceeded to use the quadratic formula to create the lower end of the light bulb to accentuate its perfect curve. I also placed the M of the parabola by 1 to perfectly align it to my desired shape. Then I proceeded to the linear functions to create the final shape of the light bulb and proceeded to add ellipses to create the inner and outer loop of the handle connecting the light bulb itself. Right after this, I created a series of quadratic functions to further give detail to the handle of the light bulb. I also added another ellipse for the plate between the handle and the light, and a circle to further give detail to the handle. The handle is now finished and I am now working on the bulb itself, which is typically made out of ellipses, half ellipses, and hyperbolas. To give details for the light bulb, I use a series of line functions to get the wanted look of a wiring inside the bulb. It now looks like a light bulb with both the handle and bulb connected. Now I move on to the shading part, which is confusing at first, but I got the hang of it after some time of shading the light bulb. In shading, I just copied the whole function and made it into a condition wherein the shaded area could either be greater than or less than the given value. I then proceeded to shade parts of the light bulb that cannot be reached by the inequalities by making more line functions to the shade areas.
Today, I will discuss or maybe give some advices on how I did the brain part. Doing the brain part seemed to be difficult at first but turned out to be pretty easy. For those who want to make something similar from what I did, just think of some equations that will make or form circles. These circles may include ellipses and hyperbolic functions, and this will serve as the outline for the brain. Don't forget to include limitations by putting curly brackets, and also know if you are limiting for the x or y axis. In addition, by putting times m on the equations, you can easily adjust the range or wideness of the ellipses and hyperbolic functions. As you can see, there are two vertical lines at the middle of the brain to show the left and right portion. To make the brain look more realistic, ellipses and hyperbolic functions can also be used.
So, in making a star figure using Desmos application, first, I use slope-intercept form to trace diagonal lines, and in every line, I put limits in where and when it will start, and also in where it will end. I've done this several times to actually make a perfect star figure. While in making the key, I used the equation of ellipse to create my desired shape for its handle and slope-intercept form for diagonal lines of the key. And same as I've done in creating the stars, I also put limits on the axis lines of the key, and that is how I made my part in creating our group logo.
I did 57 equations to form the Philippine flag, and I used linear functions to make the lines and in other equations. But the other equations are the same. In making star figure in my flag, first I use slope-intercept form to chase diagonal lines. And in every line, I put limits in where and when it will start, and also where it will end. I've done this several times to actually make a perfect star figure. And in making sun, same as I've done in making the stars. I also put limits in where and when it will start, and also where it will end, to make a perfect sun figure. And this how I made my part in creating our logo.
Now for the book. For the borders or the lines, we simply used the y is equals to a number for a horizontal line, then x is equals to a number for a vertical line. Then for the curves of the book, we used equations for a ellipse with center hk, which are the equations will be x minus h squared over a squared plus y minus k squared over b squared is equals to 1, or x minus h squared over b squared plus y minus k squared over a squared is equals to 1. For the Chinese characters, we use tables with if two dots connect, it can form a straight line in mind. Next is we also use ellipse with center hk. The equations will be x minus h squared over a squared plus y minus k squared over b squared is equals to 1, or x minus h squared over b squared plus y minus k squared over a squared is equals to 1. Next, we also use hyperbolas with center at hk2 with the equations x minus h squared over a squared minus y minus k squared over b squared is equals to 1, or y minus k squared over a squared minus x minus h squared over b squared is equals to 1. Then, we also use the standard equation of circles with center at hk, which is x minus h squared plus y minus k squared is equals to r squared.
The Baybayan's Buhay and Bahay is the final thing that is added with our logo before finishing it with the outer circles and the sine wavy circles that uses the equation of r equals 3.6g plus sine 16 theta. The Baybayans use functions like sine waves, parabolas, quadratic, and ellipses to create the scribblings onto the logo. Now that the logo has entered its final outline, our group decided on doing detailing work to further push our design and ended up with a beautiful logo that really accentuates our vision and the core values of the school. I hope you enjoyed this tiny time-lapse for the coloring and detailing of our logo. Thank you and God bless.